All right, calculus. Good to see you. Um, I love this question so much. I hope you had as much fun with it as I have in the past, because this is an awesome one. I have my washing machine going in the background, so if it's a little loud, excuse me. This question is just so great because it's talking about such a perfect real life scenario, but it's involving all of our parametric concepts that we talk about and we've learned so far. So let's go through each part, and I just want to talk about like what is it even asking us based on this question. So for the first section, it says find the maximum vertical distance from the water's surface to the diver's shoulders. So if we look at our picture, which is super handy, we're looking for this distance from here to here. And it tells us that y of t is the distance from 0 up to wherever this person is. So essentially we're thinking like, okay, at my maximum distance, I know my slope equals 0 here. So the derivative right there equals 0, and then I got to use that fact to plug back into my position function to maximize it, right? So really this is just a Unit 5 AB topic. We're just applying it now to this parametric problem. So hopefully you got this point with your group. Here were our, I don't want to show too much here. Here were our 3 points. Number 1, did you say, yes, I know that the slope is 0 right there. And so it says, hey, dy dt equals 0 only when t equals 0.36735. So essentially we solved this thing for 0. Set it equals 0, solve it. That's 1 point. Second point, did you either do an integral or find an antiderivative? Either of those are okay here. So either spam it and say this is the integral from 0 to b, which is a little tricky because you'd have to do it by hand, but that's not that big a deal. Or take the antiderivative and then say like, that is my t, plug in that t value. Either way, not that big a deal. Sorry, I was mixing it up. This is this b value, so we have that. That's not so bad. The antiderivative's not bad either. Either way, as long as you set up one of those, that's your second point. And then your third point, did you get the right answer? 12.061 meters. Make sure you got 3 decimal places. So that's part A. The interpretation is the hardest part. Part B, find A, the time that the diver's shoulders enter the water. So looking back at our picture here, the y represents our vertical distance, and I want to know what is the time when my y value is 0. I don't have a y function. I do have this dy dt function though, so that's what we're going to use, right? This is now an antiderivative question. I want to know the time. This is the one that's a little bit tricky, so I want to zoom in on this a little bit. This is a spam question because I'm saying I know the velocity. I know an initial position. I don't know when I'm going to stop integrating. So this one is the tricky one. So this is our fundamental theorem of calculus. We saw this on that one of those polar questions yesterday. We want to know the time, so we're saying here's my starting point plus the integral from 0 to some unknown time of my y velocity function. That's where we get all these a's. So that's taking the antiderivative and plugging in a as my upper limit of integration. And setting that equal to 0 because I want the height to be 0. And then at this point you can either graph this, you can use your solver function. I would graph it for sure, that's what I'm most comfortable with. But it's 2 points here total. 1 point, did you set up the spam equation? And then your second point, did you get the correct answer? I think this should be worth more. Overall, this FRQ is only worth 9, but I feel like it should be worth 12 or 15 because it's so good. But only 2 points for part B. Part C, find the total distance traveled. We know total distance formula from the time her shoulders enter the water. That's what we just found, right? So we're using that same time from part B in our distance formula for part C. This is one of those examples. Here's my biggest suggestion. if you couldn't get B, if you were struggling to find out that time, make something up. This is an example where if you don't have an answer for B, you can't do C. So write something down. Say like, hey, A is 2 seconds, 3 seconds, 4 seconds. I don't care. Make it up and then use it for part C. Because if you use an incorrect answer for part C, they won't penalize you twice on the AP test. So they'll penalize you on part B for not having this correct answer. But then if you use the incorrect answer here for part C, that's okay. You can still get the right answer as long as you've set up the integral correctly and as long as your answer is consistent. Keep that in mind, because you can game these points as much as you want. So 12.946, that's just 1 point for the integral, 1 point for the answer. Integrate that distance formula. D is the hardest part, and this is one of the hardest parametric problems I've ever seen. It says find the angle between the path of the diver and the water at the instant that the shoulders enter the water. So here's what they're saying. They're saying right here, there is an angle. Let's call it theta. Find that angle. I'm going to redraw this in a different way that maybe is more clear. Let's imagine they're diving in at a little bit steeper angle maybe, so that we can illustrate this more clearly. What we're looking for is this angle. But I don't have like a straightforward way of finding that. What I do have is a way of finding slope right there. So I could find a delta y, and I could find a delta x. Not directly though, right? Because I actually can't find dy dx. I want to find delta y over delta x, that's slope, or dy dx, or luckily I can find dy dt over dx dt. And again, it's at the same time that it's hitting the water that you found for part B. That's not all I need though, because I actually need the angle. Once I have these two things, once I have that slope, we got to think about our trig ratios. How could I find that angle? I could say, hey, that's opposite and adjacent. So tangent inverse of whatever I get for dy dx is going to give me that angle theta. It's just so amazing how this works out. Like, you do have the tools, but man, it's tricky to get there. So here's part D. It's the slope evaluated at t equals a, which is the same a from B and C, and we get this as our slope. Tangent inverse of that slope gives us 1.518 or 1.519. I think this is a really tricky question, and it's only worth 2 points. So I tried to find the average for this one, but this was way back in 2008, and I couldn't find the average data. Overall, I can't imagine it was more than like 2 or 3 out of 9, because this was tricky. Grade yourself out of 9, get ready to do the next one. The next one's a polar question, and it's also awesome.